Hello everyone. To understand the Outbox pattern, first we need to understand the problem it solves. Let's take an e-commerce application scenario. A customer places an order and the order service successfully saves the order in the database. After saving the order, the service needs to publish an order created event to Kafka so that the other microservices can continue processing the order. But what happens if Kafka is temporarily unavailable because of a network issue, maintenance, or an unexpected failure? The order has already been saved successfully, but the event cannot be published. This creates an inconsistency in our distributed system. Let's understand the impact of this failure. Order service stores the order in the orders database, but order service has not published the message to Kafka. Since Kafka never received the order created event, none of the downstream services know that a new order has been created. The inventory service cannot reserve the product. The payment service never start processing the payment. The notification service never sends an order confirmation email. Although the order exists in the database, the remaining microservices are completely unaware of it. This is a common challenge in event-driven microservices. As we have now understood the problem, we will use Outbox pattern to solve it. Instead of publishing the event directly to Kafka by the service, we introduce another table called Outbox Table within the same database. Now, whenever a new order is created, we perform two operations. First, we save the order in the orders table. Second, we have an order created event in the Outbox table with a status of pending. Notice that at this stage, nothing has been sent to Kafka yet. The event is simply stored safely in the database. The most important part of the Outbox pattern is the database transaction. Both operations happen with a single transaction. First, we save the order, then we save the corresponding event in the Outbox table. Finally, we commit the transaction. Because these operations are atomic, they either both succeed or both fail. This guarantees that whenever an order exists, its current corresponding event also exists. We can never have an order without its event. Once the transaction is complete, the order service has finished its responsibility. A separate background worker continuously checks the outbox table for events whose status is pending. When it finds one, it reads the event and publishes it to Kafka. After Kafka successfully acknowledges the message, the worker updates the outbox record from pending to published. This ensures that events are published reliably without requiring the order service to communicate directly with Kafka during the customer request. Once Kafka receives the order created event, it delivers it to every interested consumer. The inventory service reserves the product The payment service processes the customer's payment. The notification service sends an order confirmation email. Notice that the order service never directly calls any of these services. It simply publishes an event and Kafka distributes it to all interested consumers. This creates loose coupling between services, improves scalability, and makes it easy to introduce new consumers in the future without changing the order service. To summarize, the outbox pattern is a reliability pattern that ensures business data and the corresponding event are saved together in the same database transaction. A background worker then reliably publishes the event to the message broker, enabling eventual consistency across distributed systems. Let's quickly recap its key benefit. Reliable event delivery prevents lost events, maintains data consistency, supports automatic retries, enables eventual consistency, and provides loosely coupled microservices.